These are notes for worksheet number 3, molarity. Molarity is the amount of moles of solute in 1 liter of solution. The symbol is M. Molarity equals moles of solute divided by liters of solution. So if you want to find molarity, it's moles divided by liters, and it has to be in liters. So if you had a solution labeled with 5.0 M, it would mean it's 5 molar. It's pretty concentrated. So if you want to find moles, it's molarity times liters. If you want to find liters, it's molarity divided by molarity. It's moles divided by molarity. I'm not sure what I just said. So let's do number 2 from worksheet 3. How many moles of each ion are present per liter in a solution that's labeled 0.221 CaCl2? So we take CaCl2 and we have to break it up because it actually dissolved in the water, and we get 1 of those and we get 2 of those. And it's very strange considering you started out with 1 unit of something, but when you break it up you actually have 1 unit of that, but now you have 2 parts of that. It's because here you had 2 of them. So over here it's 0.221 molar, but over here it's 0.221 molar times 1, and that 1 comes from there. So this one still has 0.221 moles for every liter of solution, but this one you go 2 times 0.221 because you have twice as many when it breaks up. So that gives you 0.442 moles for every liter of solution. You don't add these up, you don't subtract them, they're just 2 separate answers because it asks for each ion. And that one's the calcium ion, and that one is the chlorine ion. Let's do some more practice. This is number 4 from the same worksheet. It says find the molarity if you dissolve 45.3 grams into 225 milliliters. Let's write the formula for molarity. It's moles divided by liters. We already have the volume. We have 225 milliliters, but it's actually 1, 2, 3. Move the decimal over 3 times. 0.225 liters. And what we need to do is to change those grams into moles. So we'll take 45.3 grams, and you have to know how to write out potassium nitrate. And 1 mole of KNO3 is 101.1 grams of KNO3. See your units cross out, cross me. Looks like, and this one you're going to divide. I meant that is an equal sign. Equals 0.448 moles KNO3. Now that is a big N, Miss A. You're going to get in trouble there. NO3. So that was our first step. That was our second step. This is our third step. Now our fourth step is to put in 0.448 moles. And we divide, and we get 1.99 molar KNO3. Final answer, 3 sig figs. The last problem is number 7. It's not the last problem on the worksheet, but it's the last one we're going to do. What is the mass in grams of ammonium chloride that you need to make 450 milliliters of a 0.251 molar ammonium chloride solution? So what we need to do is we need to find moles. We got to work backwards. We're going to go molarity times liters to give us moles. That's going to be our first step. And then we're going to change moles into grams. So let's do the first step. Molarity is 0.251 moles over liters times the volume, which is 0.450 liters. You have to change it into liters. And that equals 0.4500. Sorry, Miss A's not correct on that one. 0.113 moles of NH4Cl. So that was step 1. Now step 2, we have to change those into grams. 0.113 moles. Rewrite all this NH4Cl. And we know for 1 mole of NH4Cl, we can find the molar mass by adding up the N's, H's, and Cl's, and we'll get 53.49. Looks like we multiply these together, and we get 6.04 grams of ammonium chloride. And what this really means is if you're going to make 450 milliliters of solution that has this concentration, you need to add 6.04 grams to a beaker and add the water up to the 450 milliliter mark. This is the end of our notes for worksheet 3.